So going ahead with this chapter on concrete, this is the third video. Please make sure that you have watched the previous videos. Okay, so far we have completed the ingredients, okay, how the concrete is manufactured, what is workability, what is water cementation, various other aspects of plain cement concrete, okay, and a little bit about reinforced cement concrete also. The next subtopic is new concretes. What are the recent advances in this concrete? Concretes from what it was a few years back and how it is used now is way more different. It has been used in structural members like beams, slabs and columns. But now concrete is also used in repair mortars. Okay, and the requirements of strength and abrasion and impact resistance, these properties, they have gone to a different level now. The concrete grades that are being manufactured by using mixed design and other concrete code guidelines, the strengths have gone very high as compared to what were being used before. So now in this lecture, what we are going to do is we are going to understand a little different types of concrete, some recent advances. Now, the first thing we are going to deal with is polymer concrete. Now, what is polymer concrete? It's a highly impermeable, resistant concrete. Number, it resists all the possible types of chemicals. It resists alkalis, acids, and all the other things as well. Now, based on when do you add this polymer, whether you add it in the hardened state or whether you mix it with the ingredients, and based on the treatment that is given to the ingredients, it's classified into polymer impregnated concrete, polymer cement concrete, and polymer concrete. Okay. Now, this is a slide which is giving you comparison between all these three types of concrete. First and foremost, the application of these concretes is in a very wide range of construction activities. It's used as repair mortars. It's used as in bridges or roads. Okay, it's used a lot in irrigation works, right? And basically, why do we go for these polymer concretes? Now, obviously, understand one thing, that the cost aspects of this particular concrete will be way much higher as compared to the regular PCC or regular RCC. Okay, the reason being, this polymer that is added itself is a not so cheap material. Okay, now coming to first one, that is polymer impregnated concrete. Now, what is this? This is a hardened concrete, hardened Portland cement concrete, a normal concrete that you know. Okay, so what do you do once you have the hardened concrete? Okay, what happens is there are voids which will be formed inside the concrete. And now, if your requirement is such that you cannot afford to have any voids in this concrete, then you take this hardened concrete element and you keep it inside the solution of polymer. And the polymer can be any acrylic material or anything. Okay, so these materials are in solvent form. So what is done is you take the hardened concrete material and then you remove air from its void under vacuum or partial vacuum. Once all the air is removed, okay, suction is applied and the entire air from the voids is removed, then you keep this material inside a low viscosity monomer or polymer. Now, this can be acrylic, it can be vinyl chloride, it can be styrene, it can be chlorostyrene. Okay, now these are different materials available. There is a wide range of materials which is available. Then you keep it till the entire voids are saturated with this particular monomer. Okay. Then once this is saturated, then the concrete is finally subjected to heat treatment or radiation. Okay. Because of this heat treatment, the monomers which are inside the voids will now turn into plastic material, solid plastic material. Now, because of this, initially the voids which were occupied by air, now they are occupied by solid plastic material. Their strength, their impact resistance, their resistance to wear and tear, everything is improved. Now where is this PIC? Okay, the application part will come later. Then the next is PCC. What is PCC? Now don't call this plain cement concrete. Okay, we are talking about polymer cement concrete, that is PCC. Now in case of PCC, what happens? OPC is mixed with an emulsion of monomer. Okay, cement, aggregates and monomers all are mixed together with the water. Earlier what was happening? You were making a hardened concrete and then you were adding the monomer. Over here, monomer is used as it is as one of the admixtures. Okay, so you add it in there. Now because of this, what usually happen? You get better strength, okay, better chemical resistance, better abrasion resistance. Okay, it's more impermeable. That's why it finds its application in a lot of marine works. Okay, so what is the difference between the second one and first one? First one is you add the monomer in a hardened state. Second state, a monomer is one of the admixtures or one of the part of ingredients. So it's added in the dry, when the cement, concrete, everything is cement and the sand and aggregates, everything is dry, you mix it and then you make a wet concrete and wait it for hardening. Mind you, you don't many a times require a very high curing period for these kind of concretes. Okay. Next is PC. PC is polymer concrete. Now in this type of concrete, the monomer is used is acts as a binder agent. So what you are doing, which is otherwise the binder agent, cement is the binder agent. So sometimes you completely replace or you partially replace, most of the times you completely replace the cement with this monomer. Okay. Monomer and aggregate are mixed together and it's polymerized after placement of concrete in position. Okay. Now, pre-treatment is there. So what you need to do is before you start mixing the concrete, you need to preheat coarse and fine aggregates. Okay. This serves as an excellent dielectric material, meaning they have very good thermal coefficient. Very good in the sense they have negative thermal coefficient. What do you mean by negative thermal coefficient? Negative thermal coefficient can be, materials with negative thermal coefficients can be used as heat insulators. Okay, and dielectric materials are used as heat insulators as well as electric insulators. Okay, they find a lot of their use in irrigation areas. Okay. Now these are the application areas of polymer impregnated concrete, polymer cement concrete and polymer concrete. So polymer impregnated concrete is mostly used in precast methods. Okay, so you know those pipes or the curbstones and all these things. It's also used for bridge and deck slabs. Then PCC and PC are used in repair motors, hardened floors and irrigation works. In the description of this particular video, I am embedding 2 links. Please go through those links, see what exactly this particular type of concrete looks like, make use of this particular topic, as a lot of times you're going to study things which are not really used in the today's world. But this is something that you guys really need to do. So go through those links, you will understand what we are talking about a little better. Okay. When I spoke to some industry members, what they actually told me is this polymer concretes, they are used when the thickness of the element, let's say you are talking about floor. If the floor thickness is, let's say, around 15 centimeters, now this polymer concrete will not be used for the entire 15 centimeter. It will be a small layer on top of that flooring. The topmost maybe 2 inches or 3 inches, which will be made out of polymer concrete. So it will be an extremely tough type of concrete. You people might have heard of vacuum dewatered concrete. If you all have not heard, I will try to cover that also. That's also something which is very commonly used nowadays. Or basketball court, which is on the ground in our college, is made out of vacuum dewatered concrete. So these are very high abrasion resistance concrete. And the top surface needs to be more abrasion resistant. Let me tell you, abrasion resistance and compressive strength are totally different things. Okay, abrasion resistance is talking about the wear and tear of the top surface. You want it really tough. Okay, some places you cannot have tiles on top. But when you have tiles, there is a good abrasion resistance. But some places you can't have tiles. Let's say, for example, a basketball court. Can you have a tile on top? Okay, So you need a rough surface over which you can keep that turf, the basketball turf, and then you can move around it. Without the turf also, if I want to use that surface, you should be able to easily use it. It should be strong enough, hard enough, it should not be skiddy, right? That's why you make this kind of polymer concretes. And major application is in repair motors. Now where are these repair motors used? Anything that is damaged. Let's say, if you Google out these things, PC and PCC, okay, you will understand that most of the use of this particular type of material is in highways. Okay, when you have, let's say, if there is a huge pothole on the bridge, what are you going to do? Okay, if on bridge, hot mixing and all, any machinery which is causing vibrations is not permitted. So how are you going to make a strong concrete? So this kind of concrete doesn't usually require hardening. Then it doesn't require, I told you the curing periods are not required, also it can be completely eliminated, right? So you go for these concretes, polymer concretes. You just mix it and place it in a particular, wherever in its position, and you just stamp it, surface stamping. That itself is sufficient. The strength and the abrasion resistance and strength gain, the rate at which it becomes hard, is so good that immediately you can open the road for the normal traffic. Okay. Next is fiber reinforced concrete. Now, there are two types of fiber reinforced concrete. First is steel fiber reinforced concrete, and second is glass fiber reinforced concrete. Now, steel fiber reinforced concrete is made out of low carbon steel fibers. Now, these may be flat in cross section, they may be rounded, and these are added to concrete. Now, fibers has around 10 to 60 mm in length, that is 1 centimeter to 6 centimeter in length. Now, they are available in bundles. Why you make bundles is because if you just add these particular, like this 1 centimeter, 60 centimeter, they can become a cluster, it can become a lump. That is why they are available in the form of bundles. Around 2 to 3%, just 2 to 3% can increase the flexural strength from 2 to 3 times. Okay, it has extremely good explosion and crack resistance. Now again, these are also used in pavements, deck slabs, okay, bridge decks, okay, then the pressure vessels and tunnel linings. Okay, tunnel linings also require very high strength. You don't want water to be pouring outside. Tunnels are obviously constructed in very hard rocks. Okay, and very hard rocks are many times fissured. There are cracks, so there is water flowing inside. So many times you require good grade and very high strength concretes with good properties, abrasion resistance properties, so as the permeability and the seepage of water is controlled. Now, this is what is a pressure vessel. In this case, this is made out of glass fiber concrete. What is glass fiber concrete? Instead of steel fibers, you are going to use fibers which are made out of glass. Now, these increase as surprisingly, the strength increases as the diameter reduces. As it becomes more and more slender, the strength of glass fiber increases. It's extremely strong in tension, it is brittle, it can break, and this why cannot be used for long lengths. Okay. It can corrode with alkali. Now, Portland cement has a pH which is a little higher, so in Portland cement it can slightly corrode. That's why when you add it in OPC, you have to add epoxy compounds so that the pH is regulated. 10% addition increases the tensile strength, impact resistance to 2 folds, double. It's used in spun pipes. You can see these spun pipes. Spun pipes are used in water system, okay, water supply system. Then it's used in drainage systems. It is also used in wall cladding. I have rotated this, but this is a wall. Actual image is somewhat like this. You see it like this. Okay, this is an image. Can you see the type of wall cladding? It's such a beautiful wall cladding. Can you see this? It's such kind of, it's a very slender section. It's not a very thick wall. Okay, so when you want to make something like this beautiful, right, you go for glass fiber concrete. Okay, the remaining type of concretes we'll do in the next video.